Hi students, let's look at this new concept here, which is the integration of power functions. Let's see how we can do this proficiently. So these are the formulas that you need to know. So I would encourage you to memorize this. So what are power functions? Power functions are actually like when you differentiate, let's say this is x cubed, 2x cubed minus x, okay, plus 2. So if you differentiate this with respect to x, what you will get is actually 6x squared minus 1, right, plus 0. Differentiating 2 will be 0. Differentiating minus x will be negative 1. So this will be 6x squared minus 1. Alright, so the thing is, when we are trying to write this out, this is where the power function happens, because when we differentiate, we could just we could write it down as, hence the integration of 6x squared minus 1, okay, dx is equals to 2x cubed minus x plus 2. Okay, so with respect to this part here, you integrate this, will give you this. Now, but please take note, because this is a constant. Okay, so this can be any number. Okay, it can be any constant. Okay, you don't believe me, you just write this as 3 or 2, you still get the same answer. So when, for example, that is to say that if you differentiate when you differentiate 2x cubed minus x, 2x cubed minus x plus 10, you also get the same thing. Okay, it really doesn't matter what constant you use, so that's why we will use this as c. Okay, when we integrate this, we get back this. So this is how we write. The integration of 6x squared minus 1 is equals to 2x cubed minus x plus c. Do you see that? Now let's dive a bit deeper. So to do that a bit deeper, what we do is just put xn instead of putting a number there. So when you differentiate, what the process that you do is n, you multiply n down, and this is n minus 1, right? So when you differentiate it, you will get this. So differentiate this expression, you get this expression here. So meaning to say, when you integrate, it will be xn minus 1, and this will just be dx will be just xn, okay? And you could actually put the plus c there if you want to, but it's okay. We know that differentiating constant will be 0. So anyway, this is a constant, so we can bring this constant out. This xn minus 1 dx equals to xn. Alright, and this will be xn minus 1 dx equals to xn over n. So you could see here, this is a very neat formula here. So we can xn minus 1, we get, essentially we need to get xn and n. So it's a very complicated formula, so we might as well just let this say be k. Okay, so if this is k, n minus 1 equals to k, so n is equals to k plus 1. So this whole thing here will just be k plus 1. That's why you get this formula here, xk dx equals to xk plus 1 over k plus 1. Alright, that's how you get this integration formula here. Xn is the same thing. It's arbitrary, so k and n can just interchange. You can just interchange it, it's fine. Alright, so that's how you explain it. But just remember to put a c there. Why do we put a c there? Because we can't know for sure once you integrate this. There's this constant outside here which is not sure. Actually, once you differentiate, there's a constant, there's some information being missed out, because any constant that is being differentiated will be 0. So that's why we put a c there. So for example, if say we're told to find the integration of x to the power of 4 minus 2x cubed plus 1 dx. Alright, this will give us so this, after integration, this is what you do. You take x4, the power, just add 1, then you just divide by 4 plus 1. So it's a formula here. You just add and divide by it, and after which, for this case here, will be 2x3 plus 1 over 3 plus 1. Now this 1 here is a bit tricky. This is actually x to the power 0. So just remember that this will be x0 plus 1 over 0 plus 1 plus c, overall plus c. So this case here, what we get is actually x to the power 5 over 5 minus 2 over 4, which is actually half. X to the power 4 plus x. Okay, integrating 1 is just x. So that's how you get this. Alright, now the second formula here, you just need to take note, this has to be linear. Has to be linear. Okay, so oftentimes, so in other words, you can't use it for x squared plus 1 to the power of 5 dx. Okay, this because this is not linear, so just take note of this. But what we can use it for is any time when the inside the bracket is linear, you could use it. So for example, you can use it for say 2x plus 1 to the power of 5. This is linear. Obviously, you can do it as per normal. So you just integrate this as per normal. What you do is just 2x plus 1. Then you just 5 plus 1 over 5 plus 1. But remember to divide by the coefficient of x, okay? So divide by coefficient of x will be 2, put a plus here. So this will be 2x plus 1, 6 over 12 plus c. It's very important. So a lot of times students forget to divide by coefficient of x. Okay, divide by the coefficient of x. Great. Now why do we need to divide? It is because of chain rule. So if you remember chain rule, so let me show you how. This is dx. So you have ax plus b to the power of n. What you get is actually n, because of chain rule here, outer layer and inner layer here. So what you get is actually n ax plus b over n minus 1. Then differentiate inside will give us an a, right? So in other words, this case here, we know the integration of this thing, which is n ax plus b n minus 1 a dx will be given by ax plus b n. Okay? So same thing, you see this a here, so that's why this constant can bring it up. So this is ax plus b n minus 1 dx equals to ax plus b over n over an plus c. And once this is done, this is pretty okay. We just let this be a singular. This is arbitrary, so let k equals to n minus 1. So n is equals to k plus 1 still. So this will be k plus 1. This will be k plus 1. This becomes k. We just let this be k. Okay? So this is how you show why the formula is as such. But it's okay if you take some time to understand this portion here. We just apply the see if we just use the formula to solve the subsequent question. Alright? Yeah, you're not required to know how this is being derived. This is just for you to make sense of what's going on. Okay, so that's how you understand the power function here. So we'll see how we can just use this formula for the subsequent part. Keep practicing, and any question let me know, and I'll see you then.